Okay, try this thought experiment. Imagine you have a library with 1 billion books, but here's the catch. Only a handful of librarians can actually find anything, because they all speak a secret, super complex language. This was the exact problem the early internet giants were facing. So today, we're going to dig into the story of Apache Hive, this brilliant tool that basically acted as a universal translator, giving everyone the key to unlock the secrets hidden inside petabytes of data.
All right, so let's set the scene. We're talking mid-2000s, and Facebook isn't just growing, it's literally exploding with data. The challenge wasn't just storing it all, it was making any kind of sense of it. Their existing systems, the ones built on traditional databases, were about to hit a massive brick wall, and fast.
And just to put a number on it, at that point, users were uploading something like 500 million photos every single day. I mean, that is a tidal wave of unstructured data that old-school databases just were not designed for. Facebook had this new, revolutionary system to hold it all. But there was one gigantic catch.
And this right here is the heart of the problem. On one side, you have your traditional databases. They speak SQL, which every data analyst knows, but they just couldn't scale up to handle petabytes. On the other side, you had Hadoop, this new beast that could store a practically infinite amount of data on cheap hardware. The problem? To talk to it, you had to write these really complex Java programs called MapReduce. This created a huge language barrier.
Yeah, this quote just nails the pain they were feeling. Facebook's analysts, they were SQL wizards. They could whip up queries and get insights in minutes. But with Hadoop, that same simple query, just to count the rows in a dataset, suddenly meant writing 100 lines of complex Java code, then compiling it, then running it. Now, multiply that by the 70,000 queries they were trying to run every day. It was completely, totally unsustainable.
So this was the crazy situation they were in. Facebook had totally solved the data storage problem with this incredible new tech, Hadoop. But in the process, they'd created a massive accessibility problem. They had this gigantic ocean of data, but they'd locked out the very people who knew how to navigate it, their SQL experts. And, out of that frustration, a truly brilliant idea was born. Instead of trying to force thousands of analysts to learn this ridiculously complex new way of programming, the engineers at Facebook asked a better question. What if we just built a translator? What if we could make Hadoop understand SQL? And that translator is Apache Hive. Now, think of it like this. Hive doesn't replace Hadoop's powerful engine. No, it just builds a simple, familiar dashboard right on top of it. It creates this friendly front door that lets you talk to all that complicated big data using the language you already speak, SQL. So here's how it works, from the analyst's point of view. You sit down, you write a familiar SQL query. Nothing new there. Hive grabs it, and behind the scenes, it does all the heavy lifting. It translates your simple request into a complex job that Hadoop can understand. That job then runs across a massive cluster of computers, and the final results, they come right back to you. For the analyst, it feels just like querying a normal database, but they're secretly commanding an entire army of machines to sift through petabytes of data.
So how does this translation actually happen? Well, it's not magic, even though it seems like it. It's actually a really well-designed architecture. Let's quickly follow a query on its journey through the Hive system.
Okay, the first stop for any query is the metastore. You can think of this as Hive's brain, or its central library card catalog. It doesn't hold the actual data itself, but it holds all the information about the data, the metadata. It knows the table names, the column types, and exactly where all the data files live on the Hadoop cluster. It's the blueprint Hive has to have to understand what you're asking for. Right, so once Hive has the map from the metastore, your query gets passed to the driver and compiler. This is the real translation engine. It's like a project manager. It takes your SQL, checks it for any errors, and then starts drafting a logical plan. Basically, a step-by-step strategy for how it's going to get the answer you want.
And finally, that plan gets handed off to the execution engine. This is like the general contractor on a construction site. It takes the blueprint, figures out the most efficient way to build it, and then it sends out the actual work orders, the MapReduce tasks, to the Hadoop cluster. The cluster does the hard work, and the result gets sent back. A simple question becomes a final answer, all in one smooth process.
So, by being this amazing translator, Hive unlocked some incredible powers that pretty much made it a must-have tool in the big data world.
So what did you get with this? Well, first, mind-boggling scalability, all thanks to Hadoop. But the real game changer was the SQL interface. This didn't just help a few programmers, it opened up big data to millions of analysts. It was also super flexible. You could throw all sorts of messy data at it and even write your own custom functions.
And the best part? It was open source, which made all this power super affordable.
But maybe Hive's most revolutionary idea was this concept of schema on read. See, traditional databases make you define a really rigid structure, a schema, before you load any data. Hive completely flips that around. It lets you just dump all your raw, messy data, like log files, into the system first. You only define the structure when you actually run a query. This is a massive, massive advantage for data exploration because it lets you ask questions without needing to know all the answers ahead of time.
So what did people actually do with all this power? Well, its SQL interface and massive scale made it the perfect engine for business intelligence dashboards. That schema-on-read flexibility was a dream come true for data scientists just exploring raw log files. And because you could extend it, you could even plug in machine learning models to run predictions at an incredible scale.
Now, for all its power, Hive isn't some magic wand that solves every problem. It was built to handle a very specific type of work, and understanding where it shines and where it doesn't is really key.
Okay, this is probably the most important thing to get about Hive. It's a warehouse, not a storefront. It's what we call an OLAP system, online analytical processing. It's built to answer big, complex questions over huge amounts of historical data, like what were our total sales by region last quarter? These queries can take minutes, even hours, and that's okay. What it's not is an OLTP system for real-time transactions. You would never ever use Hive to power an e-commerce shopping cart that needs an instant response.
Yeah, think of it as the difference between a freight train and a bullet train. Hive is the freight train. It has incredible capacity. It can haul a ridiculous amount of data. But there's a lot of overhead to get that massive train moving. It's optimized for pure volume and scale, not for the split-second real-time speed of a bullet train. So when we kind of zoom out and look at the entire big data landscape, what's Hive's real legacy? Where does it fit in?
It really comes down to this. More than any other single feature, Hive was the great democratizer. It took the raw, untamed power of Hadoop, a system that was only really accessible to a small group of specialized Java programmers, and it put that power into the hands of millions of data analysts, BI professionals, and data scientists, all by building a bridge with the world's most common data language, SQL. And that kind of leaves us with a really interesting question to think about. Hive was the perfect translator for the era of big data batch processing. But today, the challenges are different. It's all about interacting with massive AI models and real-time streams of data. So what's the next great data translator going to be? What will be the SQL that makes all the complexity of modern AI accessible to everyone? Now that's the next great problem to solve.